let us study about the conservation of energy in LC oscillations. Okay, we learned that law of conservation of energy states that energy can neither be created nor be destroyed. It can only be transferred from one form to another form. Okay, that we learned. Now, same way, we're going to see the law of conservation of energy in LC oscillations. Okay, so let's take a circuit like this way. So we have a coil here and a capacitor like this way. Okay, so coil we can draw this side also anyway. Okay, it's no problem. So coil we say L and capacitor we write as C. Okay. Now we know this circuit will produce the energy. Let's see what is total energy in this case here. Okay. So total energy that I write as U, that's equal to UE here. Okay, that means energy stored in the capacitor. Okay, that's electric field plus energy stored in the magnetic field here. Okay, B means magnetic field. Okay, so what's the formula of energy stored in the capacitor? That is, we have here Q square divided by 2C. Okay, plus energy stored in the inductor is half Li square. Half Li square. Okay, so this energy stored in the inductor here. Okay, that we know. Now let's see. In the first case, we have three cases here. Okay, so first case we'll see whether the capacitor is fully charged here. Okay, that will take now. Okay. So I'll write here. See case 1. Okay. In case 1, that is we'll take here this way. We have the coil here. Okay, and we have the capacitor like this way. Okay, L and C. Okay. Imagine now the capacitor has a full charge here. Okay, that is, in this case the capacitor has a full charge. Its Q is equal to capital QM, the maximum charge here. Okay, the capacitor is fully charged. Okay, 4 positive charges and 4 negative charges are there. It's fully charged. It will give a current. The current in this case will be equal to 0. Okay, there is no current here. Okay, so in this case what happens? All the energy is stored in only the electric field. Okay, so in this case energy that will be U is equal to the full energy in the electric field. That is, we'll have here full energy. That is, we'll have here Q square, QM square. Sorry, okay, QM square by 2C. See, instead of Q, you write as QM. Okay, divided by 2C plus there is no magnetic field produced here. Okay, because in the first case, okay, we say capacitor only charged here. So magnetic field is 0. Okay, so you will get here the energy is equal to QM square divided by 2C. Okay, so this is energy stored here. So if you see the energy stored in this case will be wholly electrical energy. Okay, wholly electrical energy is stored here. So we can say this in this case, the total energy, it is wholly electrical. It means fully electrical only. Okay, all the energy stored in the form of the electrostatic energy here. Okay, now let me erase the board and we'll go to case 2. So let us now go to the case 2 here. We know total energy, that is U is equal to, okay, that is UE plus UB. That means energy stored in the electric field plus energy stored in the magnetic field. Okay, so this equation if you see that will be Q square by 2C plus half Li square. Okay, this was the equation we got first. Okay, this I am writing it for us to remember. Okay, so that we'll know and we'll use this equation here. Okay, so let's see now the second case here. So in the second case we have again the coil and the capacitor. Okay, this is a coil here and we have the capacitor like this way. Okay, L and C. But now what happens is the capacitor is given all the charge outside. Okay, and all the energy stored in the magnetic field. Okay, so the inductor will produce the magnetic field here. Okay, so the entire energy is stored in the form of magnetic field only. Okay, so let's see what happens in this case here. So in this case, what is the charge in the capacitor? The charge in the capacitor is 0. Q is equal to 0. Okay, and you will get the maximum current here. That maximum current is Im. Okay, so that's the maximum current. So now we will see what happens here. All the energy stored in the magnetic field only. Okay, and Q is equal to 0. That means this term, that is UE, this term will become 0 here. So what you will get here is you will get here 0 plus half Li square. Okay, and instead of this I also, what you must write? You must write capital I. Okay, so capital Im square you will get. Okay, so this thing here. So now what happens is you will get here 0 plus this thing is half. Okay, that is half L Im square. Okay, now it's clear. Next we'll see what to do. Okay, I will study. Okay, how to get this value of I. Okay, let me erase this. Okay, now I erase the portion here. Now let's take this full as a rougher column. Okay, this full portion is rougher column. Okay, now let's see this now. Okay, we know that from the AC circuit containing only capacitor, that is Im is equal to Vm divided by 1 by C omega. Okay, this equation we got now. Now take C omega upwards. Okay, C omega goes up. Okay, so what we get here is we get here Im is equal to Vm into C omega. Okay, this Vm is subscript here, small m. Okay, and this omega is on top. Okay, now let's see how to write this equation. Okay, and we know that in this case also, okay, again I'll draw a bracket here. C is equal to Q by V. Capacitance is equal to charge by the voltage. Okay, that will write now. Okay, so and in this case we get the maximum charge here. Okay, we're using it. So we get here Vm into Qm, the maximum charge by the maximum voltage here. Qm by V into omega. So Vm and Vm will cancel. So what you get here? You get here Qm into omega. Okay. Now let us see this thing. We know that here we know that omega, that is in the resonance condition, omega is equal to 1 divided by root of LC. Okay, that you substitute here. Okay, so what happens is we get here Im is equal to Qm. Okay, instead of omega, what you writing? 1 divided by root LC. So divide by root of LC. Okay, this equation we get. Now we are going to take this and substitute here. Okay, let's see now what we get here. So we get here half into L into, okay, instead of Im, what you write? You write this Qm divided by root LC. Okay, and then square it also. Okay, so in square, what happens is we get here half into L into, okay, and then Qm square. We will get here Qm square divided by root LC. Okay, let's square this and take the chalk here. So root LC square, what happens? We will get here LC. Okay, root will go away. So L and L will cancel. Okay, next I'll erase the board here and write down. So let's continue this now. Okay, so what you get here is you will get here on the right side, you will get here half into Qm square, okay, divided by C. Okay, this half into this term, okay, what happens? You will get, you can take out the half also. So you get here Qm square by 2C. Okay, so you can write one more line. Okay, so what you get is Qm square divided by 2C. Okay, this will be the energy here. So the first time also we got the same way only now, same answer we got. Okay, but in this case, you see the whole energy is fully magnetic only. Okay, so you can say that the total energy is wholly magnetic. That's fully magnetic only. Okay, wholly magnetic. That's the second case here. But you see, first answer also we got same, second answer we got same. Okay, energy is conserved here. Let's go to third case here. Let me erase the board. So let us now go to case 3. Okay, in case 3, okay, we'll draw a circuit here like this way. The LC circuit L and C. Okay, in this case, okay, there is some amount of charge on the capacitor also. Okay, the charge rate is Q, and there is some amount of current also I. Okay, it's flowing, and so there will be a magnetic field produced here. Okay, so magnetic field is produced here. Okay, so we have both the electrical field is also there, magnetic field also is there. Okay, so let's write this about this now. What is the energy in this case here? So charge, you see this charge is equal to Q, and the current, if you see, that is equal to I. Okay, small I here. Okay, so current I is small I is flowing. We know the energy. Okay, the total energy. Okay, total energy that we know that is what, that is U is equal to, we got this equation now, that is first is we wrote, that is Q square by 2C, Q square, okay, this is Q square by 2C plus half Li square. Okay, the sum of the electrostatic energy and the magnetic energy. Okay, now we see when the charge flows, okay, it will be like a wave only. Okay, it's like an oscillation. So the charge will vary with the time. Okay, in this way. So we know that the charge varies with the time. Okay, the charge varies with time. Okay, so what you get is, you get here Q is equal to Qm cos omega t. Okay, as a cosine wave. Okay, so now let's see this thing. I'll go to right side here and write down. Now let us see the current here. Okay, what's the value of the current? Current I formula that we know, that I is equal to minus of dq by dt. In this case, you must write minus also. Okay, now substitute value of q here. Okay, so what you get is minus of d by dt of this equation here. That is what we get here, that you get is Qm cos omega t. Now Qm is constant, so take it out. So what it is, minus of Qm into d by dt of this term, that is cos omega t. Okay, so differentiation of cos theta is minus sin theta. Okay, so what happens is you will get here this way, minus into minus will become plus. Okay, I'll write one time. So minus of qm into minus sin omega t, because differentiation of cos theta is sin theta, and then you must differentiate this omega t also. So what happens, you get here d by dt of this omega t. Okay, again omega is constant, so take it out. So what happens, you get here minus qm. Okay, minus to minus become plus here, so we can write plus term. Okay, plus qm sin omega t we get here, and then take omega out, omega into dt by dt. We know dt by dt is 1. So what you get here, that is plus qm, that is qm we can write here, qm, and then omega you can write front, and then sin omega t. Okay, the sine. Okay, this side we get here I. Okay, now what we do, now we know value of charge here, q, and then we know value of I. That you're going to write this in this equation. This equation write as equation 1. Okay, substitute the value of q and I in equation 1. Let me keep this down and then I erase this part here. See, I've written all the terms this side. Okay, let's write this now. Okay, substitute the value of q and I in equation 1. Okay, substitute the value of q and I in equation 1. Let's substitute this in C. Okay, so q and I are going to substitute here. So equation 1 also written on the top right side. Okay, so what happens, instead of q right here, that is qm cos omega t the whole square divided by 2c. Okay, and then plus half into L into, instead of I you write this term, that is qm omega sin omega t the whole square. Okay, let's just rough work on the side. Okay, now square this term here. So what you get here is qm square cos square omega t. Okay, the square you can write inside like this way, divided by 2c, plus this term we like this way, half into L into, you get here qm square omega square sin square omega t. Okay, this term will get here. Okay, now we can see that in this case here. Okay, let's see what is this omega square equal to. Okay, so we know that omega is equal to 1 by root LC. Okay, this term we know, that's for resonance condition. So what happens, omega square will be equal to 1 divided by LC. Okay, so let us see this now. Okay, let me go here. And then now what happens is you get here qm square, okay, cos square omega t divided by 2c plus this term, that is 2 is denominator L. Okay, qm square sin square omega t. Omega square term we will substitute here. Okay, so omega square is 1 by LC now. So this LC will come down. Okay, and then L and L will cancel. So let's see now, common denominator we have 2c, 2c is there. So we can write the common denominator. Okay, so let me write here, this common denominator, that is 2c, and what you get here is qm square. Okay, and then cos square omega t plus qm square sin square omega t. Okay, getting this term here. Now you can see this qm square is constant. Okay, common, you can take it out. Okay, let me erase this side here. Okay, I have erased this terms here. Let's now see here what you get here. So you get here qm square, okay, into this term here. Okay, cos square omega t plus sin square omega t, okay, divided by 2c. Okay, so what you get here, that you get here, that is the energy, left side you get here, energy is equal to qm square, okay, into cos square omega t plus sin square omega t is 1. Okay, the term 1 will write here into 1 divided by 2c. So get here energy is equal to qm square divided by 2c. Okay, take the chalk here. qm square divided by 2c. Okay, this is the term we get. So we can see that this is the third case here. This is also the same equation only. Okay, first, second time also we got same equation. So third time also we get same equation. This shows that the total energy is conserved. Okay, energy is neither created nor be not destroyed here in this LC oscillations. Okay, so this is a formula for energy. Even the formula also same. Okay, thank you for watching.